Hi, thank you for your time. Can you please introduce yourself?
Hi, I'm Josh Milstein. I'm a physics professor here at UTM.
Can you tell me about your educational background and which universities you attended?
I actually have an undergraduate degree in psychology. I went to a state school in Illinois in the U.S. called Northern Illinois University. But then I went on to graduate school at the University of Colorado at Boulder. I worked at an institution called GILA on cold atomic gases, where I got my PhD. And do you want to know my postdoc years? So I wound up working actually for a number of years as a postdoc. I went to the University of Oxford initially to continue doing theoretical work on cold atomic gases before switching to work on biophysics, which is what I work on now. And I did those at sort of a joint venture between Caltech and the University of Michigan in Ann Arbor before finally coming to Toronto in 2011.
Wow, very interesting. Why did you transit to physics from psychology?
Oh, well, gosh, that was a long time ago. I think I initially wanted to go into physics when I was younger, and then went through life and things changed up a bit and wound up going into psychology actually, and then sort of found my way back. So for whatever reason, deciding that no, I think I actually want to do the science.
I see. Can you tell me about your PhD thesis? What did you work on?
So I started by working actually in an experimental lab where what we did was we trapped rubidium atoms and brought them to almost absolute zero, at which point all of the atoms basically merge into just one giant subatomic particle, essentially called the Bose-Einstein condensate. So it's a quantum mechanical manifestation at the macroscopic level. You can actually see these things with your eyes. And so I was in the lab of the guy who basically was the first to make one of these. But through the years, I started doing more and more of the theoretical work, and then I wound up graduating actually on developing essentially models to understand how ultra-cold systems of bosons, which make these Bose condensates, or fermions, which is the other half of all matter. It doesn't make quite a condensate, but it makes a superfluid. And trying to understand these and tuning their interactions to see how they behave basically when they start to strongly interact with each other.
Wow, very interesting. Was there any point in undergrad or maybe before that you thought you liked research?
Well, I mean, when I was in undergrad, I was a little less focused than, let's say, in graduate school. So I don't think I ever did a research project quite like our students do when I was in undergrad. That never actually happened until I was in graduate school and beyond. But then I always liked working in labs. I always liked tinkering with things and playing with equipment since then.
Are there any courses here at UTM that you teach?
Well, so at the moment, I've taught quite a few. I've taught our advanced quantum mechanics class. I've taught our statistical mechanics class. I've taught our mathematical and computational physics course. At the moment, though, I'm teaching our introductory Physics 146 course for our majors, and I'll probably be teaching that for a while.
Do you have any advices for upcoming first-year students who may do research in their future?
Yeah, do well in your courses initially. That's the best way to get yourself a good research placement. And research yourself what the faculty are doing here at UTM. Everyone likes to talk about the research that they do. So ask your professors, ask professors that you like, or professors that you've had in a course that you like, or your TAs. They're all in labs if you have a TA that you get along with, or just teaching the course, helping with the course. Ask them about the work they do, and it's a great way to find out what opportunities we have here at UTM.
Amazing. So right now you both teach and do research. Can you please describe your day, just one day in your life as a researcher?
My day? I usually take my son to school. Then I come here, and it's a lot of bouncing back and forth between things that I work on. So I might go upstairs and I might talk to my students in the lab, find out how their projects are progressing, maybe try to help out with what's going on in the lab a bit. Then I might find myself during the academic year going and teaching, and at the very end of teaching, running to a meeting that I have, and then from there, perhaps running back to my office so that I can write for an hour a publication that we have while students are knocking on the door asking questions, and I'm trying to focus. And so it's being a professor is a lot of multitasking, which is hard, and it's a lot of jumping back and forth from different topics. But in the day, I'll go from being an administrator to being a teacher to being an actual working experimental physicist within a lab in sort of bursts of like an hour or two all day long, before often having to pick my son up from school and take him home.
My final question would be, are you happy with where you are right now?
Yeah, I am. You mean as far as my career?
And both
Overall
life.
And life? Yeah, I am. I have a wonderful family, and I like where I live, and this is a good job. I meet a lot of interesting people. Half the people I work with never get older because they're always coming in and then leaving, and so I'm constantly working with people around who are enthused and excited about doing physics. And I like the students in my lab. I think we have a very good atmosphere in there. There's all sorts of different problems that I can work on. I wish I could work on them a little bit more myself, but usually what I'm doing is discussing or coming up with really good ideas that I have to pass off to someone who gets to have all the fun building the microscopes and playing with the lasers. But that's just this stage, basically. And I learn something new pretty much every day, which is a neat thing about this job, and I think why I was attracted to it in the first place.
Amazing. Thank you so much.
Thank you.